Although you can also record on your side if you request permission. So welcome today. I'm Mr. Hendricks. I am gonna ask you maybe later to put on your screen so that I can just do attendance. Huawei likes to have screen share, well, video feed, just screenshots of it just for attendance, to see who attended. Also, I'm also looking at if you guys really understood the basics that I'm going to cover in the next 3 days. And if you want to go more in detail with the other component of that I'm not going to cover, which is Fusion Compute and Fusion management of that on a Huawei stack and all that, you can attempt to write the exam, which is the HCA exam, and I've got vouchers for you. So if you interested and you feel like, yes, I want to attempt that, keep in mind I need to see obviously if you're really interested in doing it, because a voucher is like $200. So that's almost what's our rand currency. It's almost what 2,000, 4,000 rand. Yeah, I think it's about 4,000 rand. Yeah, so that's basically the voucher value. But also it's just if you really feel like you want to go and attempt that. Right, so I'm going to switch off my screen now, and then I'm going to start with the presentation. So what we'll go through today is the basics of cloud, and we'll first start with that. You can raise your hand if you want to ask a question. There is a chat available for you, but by default, you should be muted. Okay, so I'm going to start sharing my screen. We're going to probably take breaks in between. Tomorrow we'll start at 9 o'clock. Today is the only time I had to start now. Right, so I'm going to start sharing the PowerPoint, and you should be able to see the PowerPoint in front of you, which is a cloud basics. And like I said, you can also access the PowerPoints also on the website. And I think you can also attend, I think there is like an online video course also available for you. Right, so let's jump to the nitty gritty, and we'll just continue with cloud basics. So what is cloud basics? Remember, you live in this world where you hear the word cloud, uh, and so what cloud basics means, or what cloud basics what we're going to cover, is really understanding what is cloud computing. You will learn terms like infrastructure as a service. You'll learn terms like platform as a service, and you learn terms like you can use any other thing, platform, infrastructure. There's also a software as a service, right? So these are cloud models, and these cloud models is what we'll go through and what you will learn. These cloud models are also applicable to if you want to learn about AWS, if you want to learn about Azure, sorry, it's spelling there, Azure, Google Cloud, right? Google Cloud also have the same, and many other cloud vendors. They have the same model. So you learn about how does these models work for certain applications. And so we'll basically go through that, and just really see what you can cover on that. Right. So moving on, um, when you look at the IT sector, we live in a fast-changing industry, right? You guys are most probably third year. I didn't ask that question yet, but I think I've assumed that you're going to go to the industry. The industry is really changing very fast, and you need to keep up with the pace, right? So more or less, what we've learned in the past is that cloud computing, the likes of AWS in Azure and Google Cloud, they are more or less the let's say the front runners in Huawei Cloud. But what we're doing in this course is to really show you really how the cloud is built. You don't see this normally at other vendors where they would give you cloud computing, the course, AWS, but it will tell you how to use the front end or the services and how to work with clients. They don't really tell you really what's the back end, which is virtualization. And we'll go through that and we'll learn about that, if it's not more that you already knew about it. Okay. And then basically, then we're going to look at the models as I just mentioned now. So the completion of this particular topic or model would be to look at describing what cloud computing is, describe the benefits of cloud computing, list the services and deployment modes, which I just showed you now, and also understand the mainstream cloud computing vendors. And we'll look at those vendors lastly. We'll get to that. Right, so let's get to what is IT, right? You've seen IT. You using IT now. You on WhatsApp, right? You on particular application that you would use. So in this case, there's taxis, but you remember, there's Uber, right? So you would use Uber. There's other apps that I can't think of now, but I'll just use Uber for now. And so Uber is basically a service without any cost, right? It's there. You use the app, you book a car. The car is a taxi service. You pay for the taxi services, but they don't use or own any cars. The cars are basically the um, people that work for Uber, right? People that wants to use the service, and that's basically a service without car. And that's how IT has changed and evolved. A lot of things you have hotels, which literally like Airbnb, uh, and many other breakfast kind of hotels. But this again is an app that you use without the hotel owning any rooms. It doesn't exist because it's using that service, and that's basically where we're looking at how IT can evolve. And this is innovation. When you look at messaging calls, WhatsApp, WhatsApp doesn't have a service company. They don't own a network, but they are on the network. They allow you to communicate. They allow you to chat to people. They allow you to do video calls, voice calls. Yet they don't own a single network. They are using their method of mode through the networks that exist. And that is basically how they operate. And then last, you have retail. Retail, you can think of Take a Lot. Take a Lot are one of them. You can think of, I think for senior has this TFG app, which is called Bass, right? And so again, it's a shopping mall or a store where you can buy all these things, right? But you don't own a single physical store, and that is really how IT has evolved with regards to the spectrums around everything, how everything gets processed, and how things are working around us currently. And so this is just giving you a nutshell of what it is. Now, looking at the data center, now this overview that you see here, don't get scared really about the whole layout and all the things you see. It's more or less just showing you really how things work in a data center. This is a data center. Now, if you haven't seen a data center, can quickly, I think you probably haven't heard about the Google data center or so, but I'll quickly just show you, just to give you a perspective of what is a data center. And I'll just see if I can bring up, maybe it's like 5 minutes
data centers.
So I'll try to just do that. Let me just stop sharing quickly while that's running, and then I'll just join it again. So let me just say again, and this time I'll say Google, and then include audio as well. Let me just do that. Okay, so what we'll do is I'll see the audio now, and you could see Google, they're playing. And so this is basically just Google's data center that we're looking at.
The brains of the internet.
The engine of the internet.
It is a giant building with a lot of power, a lot of cooling, and a lot of computers.
It's row upon row upon row of machines, all working together to provide the services that make Google function.
I love building and operating data centers. I'm Joe Cava, Vice President of Data Centers at Google. I'm responsible for managing the teams globally that design, build, and operate Google's data centers. We're also responsible for the environmental health and safety, sustainability, and carbon offsets for our data centers. This data center here in South Carolina is one node in a larger network of data centers all over the world. Of all the employees at Google, a very, very small percentage of those employees are authorized to even enter a data center campus. The men and women that run these data centers and keep them up 24 hours a day, 7 days a week, they are incredibly passionate about what they're doing.
Okay, so I'm going to just skip to the fun part. Not that really, that's just a guy talking, just to take you inside a data center.
Verify that it truly is me. Okay, here we are on the data center floor. The first thing that I notice is that it's a little warm in here. It's about 80 degrees Fahrenheit. Google runs our data centers warmer than most because it helps with the efficiency. You'll notice that we have overhead power distribution. Coming from the outside yard, we bring in the high voltage power, distribute across the bus bars to all of the customized bus taps that are basically plugs where we plug in all the extension cords. All of our racks don't really look like a traditional server.
So just to pause there, as you can see, those at the back of this architect or technician, those are services that's basically having all your data stored on that services. And so they have millions of these services running, or probably thousands. And those are basically, they need power, they need cooling, and there's a lot of features and things. And obviously, you need to know that this is also the network switches that needs to connect to these services. How
Server
everything
racks.
works.
These are custom designed and built for Google so that we can optimize the servers for hyper efficiency and high performance computing. It's true that sometimes drives fail and we have to replace them to upgrade them because maybe they're just no longer efficient to run. We have a very thorough end-to-end chain of custody process for managing those drives from the time that they're checked out to the server till they're brought to an ultra-secure cage where they're erased and crushed if necessary. So any drive that can't be verified as 100% clean, we crush it first, and then we take it to an industrial wood chipper where it's shredded into these little pieces like this. In the time that I've been at Google for almost
Yeah, all right. So that is basically I wanted to show you, and obviously there's the cooling part, as you can see. So it's very important, right? So these are all the things that works around a data center. Yeah, I'm not gonna play the video a lot, but I think that's all I want to say. So let me just get back to my presentation. And then so that is basically just showing you what a data center is. Now I'm gonna go into our presentation now again, which is just mentioning that part. Right. So getting back to our presentation, what you would have seen is that there's this part of, well, I think cooling facility that you just saw now in that video, right? You saw the power supply, how everything needs to be connected to the servers. You also saw the cooling on the last part of the video where I showed you those big tanks on the outside. Those are the cooling. And then also there's the floor space that you saw where everything is hosted, right? So those are part of the data center, and those are not really the core things. Yes, it's a core of the back end of it, but for you to understand, it's the ones that selected here in the blue line, right? So that's why I just wanted to give you that perspective there at the bottom, and then just really now show you what it is, what's we're looking at. Now, when you look at the data center, you need to think of the hardware, right? Hardware is very important. It's your servers that will host and run all your applications and your software. You need to think of storage again. You need to think of the networking aspect, and you need to think of security, right? And so, again, when you look at this model here, you really now look at what I showed you earlier, the cloud development models, or the cloud different models: software as a service, platform as a service, as well as infrastructure as a service. And when you look at this in a vertical way, right, or if you look at it horizontally, depends on how you look at it, you would basically see that infrastructure as a service, I have a line here going through here, which probably ends there. Soft platform, and platform would probably be somewhere here, and then the SaaS would be on top of that. What does it mean? I'm creating three different layers here, right? So there's one layer, there's a next layer, and there's a third layer. The third layer is infrastructure as a service, and what this tells you is that the cloud provider would then obviously give you a infrastructure as a service, which means that you get access to a cloud operating system, being that whatever it's going to run on it. But that's basically the cloud provider's responsibility. With assigning a virtual machine to a particular client, they then have that authority to do that, and that's why it's infrastructure as a service. When you look at platform as a service, you then have the middleware, which is like your normal applications that would run on a particular system. And I'll explain basically middleware is like you have maybe a Java framework that needs to work with a front end Java application, or you need a PHP framework that needs to work with a front end Laravel website or something, or you would need the database services that would connect to the real database, right? So those kind of things, um, and as well as the management of the database, and then if there's any analytics in that. So that will be the platform as a service, and then you then have your software as a service, which then is the particular app that you would run. You might want to run a enterprise resource planning service like a ERP, and a typical ERP can be SAP. SAP is an ERP. You have other ERPs out there. You have Oracle, and there's many big vendors out there, right? CRM, customer relationship management systems, could also be one of them that you would use. So these are just really giving you in a nutshell, basically an overview of how the data center work, where everything sits in the data center, and really just showing you where things are sitting, right? So you could, in a way, in service it by consulting. So you can play consultant and understand all these services. You could be part of the integration of the system. You could even outsource IT resources if needed, and also there could be training also. Again, this is just an whole nutshell to show you basically what is a typical based IT architecture in a data center. Right. Now, what is the challenges to some of that systems, right? More challenges that we get is that the information explosion. And what we mean by that is that the internet is expanding, right? You might have pieces that you used to have, which probably would run the normal x86 architecture. And what we mean by architecture is this type of CPU that you would run. Nowadays, I mean, if you talk about today, we have ARM, right? ARM CPUs, right? We have ARM type of architectures. And that means that you want to have a laptop or a device or a server that doesn't use a lot of power resources. So it's like lightweight. The CPU don't process a lot of information like it used to be in the older days or in the past. It has like a quicker response to maintaining the power consumption. So power consumption is really, really low, and that is why we have the CPUT type ARM. You also have x64, which is another uh, kind of processor CPU. And so again, as information exploded, we tend to lean now towards ARM. And you will notice ARM, if you buy an ARM CPU, it's very, not buy it, but if you buy a laptop that's an ARM laptop, you will pay almost like 50K, and that's equivalent to a Mac, right? But again, it's more about because it has this whole low power consumption, which is what a lot of people would want nowadays, right? You don't want to have a lot of resources running. Then you have obviously your operating system, your Androids. Those will probably run this particular ARM architecture. And again, now we've seen basically how things evolve, right? ARM used to be on Android and iOS devices because it's small devices, right? Now ARM has moved to laptops. Even Macs that comes out now have the ARM CPU. I think it's the Apple Silicon. And so again, that basically tells you that we live in an era where we want to have less power consumption, and that is basically how we're saying information is exploding, right? There's IoT devices also out there, and they also have different type of architectures that's needed to run. And so, because we're adding more devices and everything is just added to the new network, you need to expand your IT infrastructure. And so your traditional IT infrastructure can't handle this. There's scalability that you need, and that's obviously why people just jump to the cloud. But what if you understand this and really look at what if I set up my own local cloud, those kind of things. And that's also what we're leaning towards for you to understand. So what is the challenges to traditional IT? There's a few of them. There's slow service rollout. That's number one. What happens there is that you have procurement, right? You buy a piece, you buy a server, and you have to wait for parts to come in. And maybe you order the wrong part because certain parts are made for a certain PC or server. And so that is where you have slow service rollout. Limited scalability also is also a problem because you can't scale that data center. What if your data center is fixed as you can only have 5 servers in the data center? Now you got more people coming onto your company and so forth, and now you can't expand the data center because there's no scalability. And that's obviously why we're saying that is problems with traditional IT. And people then jump to the cloud and use the cloud as a kind of a hybrid model. There's also a complex lifecycle management, and what it means by that is that parts fail. You saw in that video now where a drive would fail and then you would destroy the drive, but you need to get the same drive. But then obviously, as manufacturers create drives, you need to do testing also and see can this drive handle the capacity, the input output processing that's needed for it to process. And so it becomes a complex lifecycle management of hardware and software to maintain. There's also a low reliability, which means that those, as I just mentioned, our hardwares are not really reliable. If your one server goes down and there's no backup server, you have a problem, right? No one can access your services. And so that's basically where we're talking about that. The latency also with input output bottlenecks. That's also the network itself. You might have a server that has, let's say, 10. Well, because servers normally have 10 gigabit cards, right? So that's a card, a network card. So as information travels to your network, it must go through this 10 gigabit link, right? So that's like a link. And so what if you have a lot of information coming in to that link, right? The link will obviously run out of probably trying to keep the congestion, so you would end up having bottlenecks, right? And so again, that is also one of the problems. Now if you scale, if you have more servers and more network capacity, you could avoid that, but that's also latency that basically gets created, where packets gets dropped and so forth. And then lastly is the high TCO. What does TCO mean? Total cost of ownership. What it means is that you buy a server today, you maybe buy a Dell, it's a Dell, and now the Dell spec has what, 64 gigabyte RAM. And now what you're doing is you now need to buy more because you're probably running a AI application on top of it. So now the high cost of ownership means that you have to go buy that specific RAM. You need to make sure that that RAM fits in a specific motherboard. You need to make sure that the RAM type have, whatever it needs to do, it might doesn't need to use a lot of power. A lot of factors have to go in there, and that creates the high total cost of ownership of your hardware. Right. And so those are the traditional challenges with IT. So when we look at discussing these things, you kind of have to think about how are you going to transform your infrastructure, how are you going to think of resource integration, and how to utilize your information, and also understanding the business collaboration and continuous optimization of those things. Those are really thinking about if you're going to consultation, if you want to consult companies how to move to the cloud. Those are things that they need to think about, because you have to consider that you're taking a step into the cloud where it's an unknown world. Are you really sure you want to put your data in the cloud? What's the cost of removing your data if you're really tired of the cloud? Those are certain things one have to look out for. But yeah, let's look at how people are migrating to the cloud. So first of all, you have your traditional IT architecture. We just gone through that. We just explained that, and we said that you have like two servers. So there's server one, there's server two. What it means is that on that server you have your operating system running, and so most cases we would run Windows server. We would run maybe a Linux. I'm not sure if it's a Linux server, but you could run a Linux server on top of that, right? And you would have your application running on. So the application might be a website that you would run here, and you would run then maybe a email. Well, let's say a file server. Let's make it a file server. So those are the two type of servers that you're running on your traditional hardware in your kind of setup, because your clients might want the website, and the website is there, and then you might also need a file server to store files so that you have backup files. Now what you see here is there's an isolation here, and I'm just going to try to change the color and maybe make it green. And can I make this thing larger? Okay, but that's probably the only thing. So you would have an isolation here, right? And what it means is that this isolation creates problems, because these two services need to talk to each other. And if this one is down, you have only a file server and your website is non-existent, right? So that's kind of what happens in traditional IT, and we normally call this a monolithic approach. What it means is that everything is mono, it's there, it's just there, and you can't do much, right? Now we've learned, obviously, in I think 2010 VMware started with virtualization. And so with regards to virtualization, we now have this thing of running everything in a kind of cluster. So it will be like a cluster, and then the cluster basically have all your virtual machines sitting there in a kind of a pool. So a pool of virtual machines would sit there, right? And so what you would do then is you would then spin up a virtual machine using this virtualization layer here, which is called virtualization, which could be in this case be VMware. Let's make an example of VMware. And then on top of that, you would have your operating system running, and then your applications, which could be the similar. But what you see in the difference here is that you now have the virtualization layer combining with previously there was this isolation between the two. You have the virtualization layer combining the app 1 and app 2 to work together because they are on the same kind of virtualization platform. Right, so that's basically where you look at virtualization, why it brought back this difference that we needed to have with regards to our traditional IT. And now we have cloud. And so what did cloud do? Again, same story. It still has the same concept, right? Virtualization architecture. All cloud did is cloud created a cloud OS, which you would have Azure, you have AWS, you have Huawei Cloud, you have Google Cloud. And all it did is it basically created bunch of data centers. And so these would be called zones. So you have zone one, and you would have a zone two, and these zones then create, you could have a third zone here, um, and then you will create a high availability zone. So these zones would all connect to each other to create a high availability zones. So we'd have three zones. If something goes down with zone one, you would have zone two and zone three still having your data performing well. And that is what cloud is. That is basically cloud computing. It's basically taking all that different data centers, combining it into a zone and different locations wherever it's based at, and that basically creates this whole cloud architecture that you see here. Right. So that basically is just giving you why people are really thinking about migrating to the cloud, because they think of all these benefits, not knowing that there's the unknowns. And so the unknowns is more or less, there's a lot of applications running on the internet, right? We first started with the mainframe. In the old days, there was the mainframe platform, one single PC or server that had to do a lot of things. Then they moved, obviously, adding networks, right? So when you added networks, you now have your systems connecting to each other from different locations. And that's where the internet started and where services got involved. And now, when we look at 2012, that's where we looked at cloud, introducing cloud, the big data, and also the mobile internet and IoT. Those are the evolution of how things started from millions of applications to billions of users. So we had millions of users at first, and now we have billions. We could have trillion users. We could have what's after trillion? There's can't get the name now, but anyway. So you could think of all of that. You have petabytes, and then you have more than that. So it goes and it just creates more chaos on the internet with all the data expanding. And so again, that is basically cloud computing and really just showing you how the evolution worked from traditional to cloud OS that we have now. Now, what is a computer? You all know what a computer is. A computer is basically just this electronic device that allows you to do numerical and logical calculations. However, that's the CPU's job. The CPU takes all that information that you get, performs the numerical operation, does the logical calculation, and then give that information out to you on the screen either, or it processes it and does other things with it also. Again, when you look at the timeline of computer history, right, it started in the 1989s. Moving on, we then got IBM started its own computer. Then moving on, we got to the first computer with color graphics. I think that was an Apple. And then we moved on further till we got to now really looking at how we can use memory better for us, right? Looking at DDR that replaced that SD-RAM, expanding the hard drive capacity. Those are all the things that happen with computers, right? And then obviously in 1998 you have the Celeron CPU that obviously made its own appearance, but then obviously now we have i3s, i5s, i7s, and you then even on server operating systems you have Gen 10s, Gen 11s, which is basically how everything evolved. Right, so let's look at virtualization. What is virtualization? So virtualization really is more or less taking that particular hardware that you have, the resources, and virtualizing it into a pool. And so what you see here is that you have three servers. You have server 1, server 2, and server 3, right? And so you can see this is the old way, right? You have your server there isolated. It has its own CPU, its own RAM, its own graphics card, and the storage disk drive. That's basically the traditional way of servers that you would run, right? And you would run everything on top of that one server, not knowing that if the server goes down, everything else is gone, right? Your data is also gone if something happened to that server, right? Now, when we look at this, you then really see that it's called basically tightly coupled, which means that everything is tied to the hardware. If something happens to the memory or the hard disk or the CPU, that piece is good as dead, means nothing, right? And that's basically what you see here. You see the operating system running on top of it, and then application running on top of it, which could be a website or a file server or any other thing. Now, looking at virtualization, you have this virtualization resource now where you have a layer. Remember, we in the previous slide you saw this layer that I was referring to. This layer could be, like I said, VMware, and I'll show you quickly just a demo on how VMware works. And then also you could have any other virtualization. You would have Dell. They also have virtualization. You have Huawei. You have OpenStack. You have there's many other things out there, right? And all of them use the same kind of concept. Okay, some might be better, some not. Now, with regards to virtualization layer, this is on top of the hardware. This is the layer that you see here. And then obviously on top of that, you have your resource pooling, which now basically pulls all the resources together. So if you had, let's say 4 CPUs here, you had 4 CPUs, you had 4 CPUs, it will tally up the total here, and you would then basically have the amount that you would have available here, right? So you would have 12 CPUs then as part of your pool, right? Instead of having only the 4 on that server, which would run that. Then what that will mean is if you have maybe your RAM would be also added, so you would increment all of this, and then you would maybe have, let's say, 40 gigabytes of RAM in memory. So I'll just call this RAM. And then your storage might be 100 gig, right? So you might have 100 gigabytes, spelling wrong, 100 gigabytes of storage in total, where all of these are all added together. And that is the resource pooling that it allows you to do. And you can test that. There's applications called VMware, I think Workstation. There's Oracle VirtualBox, and there's many other things. There's even Proxmox, which is another tool, which is also nice, which you can use to virtualize your hardware. I think most people go towards Proxmox now. And so what you can see here basically is that with that virtualization layer, we can then assign a resource to Windows 10. Maybe Windows 10 needs only 4 of that, which means you would have 8 cores remaining, and then you have to spread that 8 cores amongst these devices if you had only that. So I think in this case you might have 120 CPUs if you add maybe 40 CPUs per server, and maybe the server would have 20 cores. So you would have 20 cores times 2, right? On a server, because that's what normally what be a CPU size would be. CPU can never be 40 cores unless you're gonna buy a expensive CPU, but you would get away with 20 cores or 16 cores, and then you would have in the server you would have 2 slots. So you would have, and I will get to that later on when we look at the hardware of a server, that you have 2 slots. You not well, like a PC have only 1 slot for your CPU, or you have 2 slots. You have a CPU A and a CPU B, and then for each CPU you have memory also for each slot also available, and that's basically how a server is built. Right, so let's look at the timeline of virtualization history. So again, you have the virtualization started in 1964, and moving on, we have now VMware that launched its virtualization products in 1999. And then we moved on, and then obviously we have HP that launched their particular virtual machine. And then Microsoft Hyper-V started. And then if we move on further on, we see that Docker launched in 2013. And then obviously now in 2012, we had before 2013, we had IBM, Red Hat, and HP and Intel that formed an alliance to accelerate KVM. Now, when you go do your Huawei HIP, you learn about OpenStack, which is KVM, which means it stands for Kernel Virtual Machine. It's a Linux kernel virtual machine, and it allows you to, and I'll show you that later, it allows you to basically use your Linux operating system fully for virtualization and not have a layer on top of it like VMware. That's the difference between the two. Right. So we can look at the definition of cloud computing. I'm just checking time here if I can take a 5 minute break. I don't want to talk too much and then you guys fall asleep because it's online. I think it's 11:36 now. I thought I wanted to go 30 minutes per time. So if we take a break till 11:55, which should be, yeah, and then we can continue again so that you guys just have a breather. Or let's make it quarter two. Yeah, let's make it quarter two. It's now 36. Yeah, so we'll make it quarter two, then we continue again. So you guys just have a breather with regards to the content, but throw your messages in the chat so that I just really see if you guys are still with me and you understand really the concepts that I'm giving you, which this is just the basics of cloud computing. Thank you. So we'll take a break till 11:45. Right, we're back. I see my screen disappeared. So let me just see what happened there. Could you guys hear me now? Because I saw in a message that was probably in a different chat because I saw a chat happening and I didn't know what it was about. Okay, let's continue. Can you guys still hear me? Am I audible? Can someone just leave me a message in the chat if you guys can hear me? Can anybody hear me? Okay, cool. That means you can hear me. Thank you for raising your hand. Thank you. All right, so let's continue. Thank you for that. Okay, so we're gonna continue where we stopped. I'm just checking my recording is still running. Yeah, it's on 44 minutes. So that's good. Right, so let's continue with our second part. Okay, so right. So where we paused earlier was looking at the definition of cloud computing and just really see what it's about. So there's the National Institute of Standards and Technology (NIST) that defines cloud computing as the following. And so we're just going to look at what it means. So it means that cloud computing is a model that enables everything to be convenient. It's on demand, which means that you can access the cloud at any time as you want it, right? It's not like you have to go log in and put in a username and password and then you have access to the cloud, right? It should be there on demand, right? So it's a shared pool of different resources altogether, your networks, the servers, the storage, the applications, and as well as services, which then gets released, with a minimal, management effort or interaction with service providers, which means that you don't have to worry about Azure or cloud, Google Cloud. You would just basically go on Google Cloud, you create an instance or you build something or you build a website, and that's it, right? There's no interaction with who they are. You have that model available, and that's basically what cloud computing is, right? It provides that whole service for you as a user. And so when we look at different cloud compute services out there, you have cloud albums, and then obviously this is just Huawei's terms. But remember, you have your iCloud, right? Your iCloud, for those who have what's it called? You have what's the other thing? There's other things also. I think Facebook has it also. So there's many other type of cloud audio cloud service that you can use, right? And so that falls under that category. You also have cloud music. Again, you could use many other ones out there. There's SoundCloud, which is basically a music cloud where you can just go there, go listen to sounds, and you come back and then you have the music without downloading it. You can go listen to it, right? And that's basically SoundCloud. You have obviously cloud video, and that's common, right? Cloud video, you could use YouTube, you can use Facebook. All of that is basically out there for you to use. You go on YouTube, you go on Facebook, you play the video, and that's it. You don't have to sign in. Yes, sometimes you have private vendors that would allow you to sign in, like LinkedIn Learning. We have to go pay to watch the video. But we're talking here about the public cloud where you have the likes of YouTube, Facebook, um, even Google Drive, where you can even say stuff. You can use all of that, and obviously leaning towards Google Drive is Cloud Docs. So you have even Google Cloud, you have OneDrive if you have Microsoft, and you have if you have Google, you would use Google Cloud, and many other cloud information drivers out there. You have Dropbox. Dropbox is also cloud shared service where you can drop files and have it accessible. And then again, you have many other vendors out there. These are all just cloud service and applications that you use, that you're not aware of, but they are obviously out there to help and make your life easier. Okay. Now, when we look at cloud service and applications, basically, we have this app that you're all on now, which is called Huawei Cloud Meeting. And so, yes, I understood that earlier. I see in the chat that some students couldn't join, and so that is the importance of how you have to use a application as well as the backend of the service. So, when we look at what happened earlier with students couldn't access the video conferencing or this live streaming, and I mentioned in the chat that I mentioned port 80, right? So port 80, if you know your TCP, right? So I'm talking about TCP transfer control protocol. Port 80 is a HTTP service, right? You know, my cursor is jumping here. And then that means that your web server is unsecure. And so what it means is that if it's unsecure, it means that some web browsers like Google Chrome, Safari, and many out there won't allow you to go to that link unless you have a HTTPS link, right? So if you look at HTTPS links, you would have, I'm going to do it at the bottom, you would have 443, port 443, right? And so port 443 gives you the HTTP S link, which means it's HTTP traffic, but it's secure. The S means it's secure, right? And that most common websites that we visit today nowadays have that availability, right? So you would basically go, to that site, and you know that it's there, it's secure. You can go to a banking site, you know it's HTTPS, it's secure. All those things. But when we look at the site that's not secure in our current area, our web browsers are basically built to only allow HTTPS because of hacking, because of the bad guys out there. Those are the precautions that they put in, and that's why some of you couldn't access the link, right? And that's the reason around that. But also sometimes you put files under a port 80 because you feel like, why do you need to put it under a secure link if it's just a file into download? But web browsers are not that intelligent to pick that up. Even the website administrators that build these things are not allowing port 80. You could be on your internal network, and you won't be able to access port 80 sites because they are afraid of sites that's bogus, that will reroute you to the wrong site. Because if you look at that link that was shared with you in that chat, it's a port 80, right? It's a HTTP link. However, there's a redirect that it redirects to a port 443, which is HTTPS. And that redirection, the web browser don't sometimes see that, or the client. And that's basically why some couldn't actually access the link. So I just wanted to give you in a nutshell really what happened there in that with that students, and why they can't access it and why some can't access it still. Because it's now to do with the mobile app. The mobile app is not intelligent enough to figure out the difference between a redirection. And so that's basically what we're experiencing with some apps. And you would then probably just want to use rather a laptop or PC. I know you want to have the mobile feature, but I think sometimes rather download the APK separately, and then you download and then you log in with the APK. But using the web browser and downloading it on your mobile phone is going to cause that problem. So if someone has downloaded the APK, you can then say the APK to the students, and then they would have the APK. You just click on it, install it, and then that would be it. Right. So I thought I just wanted to cover that in a nutshell with regards to that. Okay, so when we look at the development models, and I mentioned earlier the software as a service and the platform as a service, we then also have cloud computing models, right? And so we currently have Cloud 1.0, which is where everything started. We have Hyper-V. Hyper-V is part of Microsoft. It's how Microsoft runs their virtualization software. You have Zen and KVM, which I mentioned earlier, the key kernel virtual machine. And then you have VMware ESX, which is basically the server platform of VMware. That is basically Cloud 1.0, and that's basically high resource utilization, which means that they are power hungry, they are resource hungry, and you can't run anything on a laptop on that model. That is meant for computing, pure computing. meaning it takes your CPU, it takes your RAM, it takes your hard disk, and it virtualizes that so that you can have more resources available for the users than for some. And then you have cloud computing model 2.0. This is now where we have SDN or software defined involved, right? And so here we have the likes of OpenStack. You have VMware, and you can see it's not the EX, it's not the server platform, the hypervisor, and you have AWS, right? These are the software defined integration models. These are 2.0. So with OpenStack, you basically can take a virtual machine, run it in the cloud, and then have a virtual network. When we go to network basics, I'll show you that. Create a virtual network without having a real network, and that's virtualization with OpenStack, which they use Open vSwitch. And so again, that is basically how the cloud infrastructure works, and how you try to automate resource services to clients. And now we have cloud computing 3.0. I'm not sure there's a 4.0, but this is now cloud native. And what does cloud native mean? It means that you are natively running something in the cloud, but not really hardcore. You're not running a VMware in the cloud. You're running it natively, right? Lightweight. And that is the likes of Docker. Docker is basically a container. You run the certain dependencies of the website on Docker, and the rest is not really needed. It's not a full operating system that's needed. And then you have Core OS, which is also a lightweight operating system. And then lastly, you have Cloud Foundry. These are all just different vendors. But again, it allows you to have a cloud native application that's lightweight and to run that application. You can actually scale it up to 1,000 instances if you need it, or you can scale it down to 15 or 10, depending on what's the use case of that application. And and that also helps with lifecycle management of certain apps. So these are just the three different development models of cloud computing. Number one is looking at hardcore servers, which probably have a lot of resources, like the Google data center that I showed you in a video. That is where you would typically run a Zen, a KVM, or Hyper-V. Then you have your cloud computing model 2.0, which now looks at the software defined way of cloud. That's basically how the cloud would run locally, like your local cloud. You would have the likes of OpenStack, or you would run VMware or AWS. That is basically your cloud computing model 2, right? And then you have your native one, your cloud native. Okay, so let's look at the feature of cloud computing. Now we've looked at the features of traditional IT when we started off, right? And that was all the bad things I said about traditional IT. But now we're going to look at let's say, the features of the good things of cloud computing. So one, it's an on-demand self-service. What it means by that is that you can access the resource at any time you want, right? It's on demand, it's available there for you, and it allows you to access the service and do what you need to do in the cloud. And I'll probably quickly demo that to you also, just to show you basically what is on demand. There's also a wide spread of network access available, which means that, as I mentioned earlier, you can access from anywhere, right? You don't have to be just one data center. There could be different zones where it's located across the world. And that's how you could access AWS or Google Cloud or Huawei Cloud, wherever you are, because of the widespread network access capabilities. It's a metered service. What do we mean by that? They will charge you per billing. It's a pay-as-you-go service. So it's like you buy a SIM card, it's a prepaid SIM card. If your airtime is finished, you have to go top up. The same with metered services. You have to top up if you run out of resources. However, some models are so rigged that it doesn't tell you that you've gone, through your limit. They bill you or they charge your credit card. So with the cloud, you have to be really, really responsible to look at your billing. You have to look at budgets, because you don't want to overspend a certain month on a resource, and then the next month you can't handle that resource, or you have to go into a minus, and then you owe the service provider. So it's really important that you look at billings and all those things, and budget control when you deal with cloud services. You also have quick deployment and auto scaling, and that is where I mentioned you have, let's say, 100, let's call it 100 websites. Well, not really websites, let's say web servers, because that's basically what I'm going to look at. 100 web servers that you're running now. Then you want to scale them down to, let's say, 50, right? So 50 web services. And that's basically what you can do with quick deployment and auto scaling in the cloud. You could run 50 web services, have the resources, and then you can scale up the available resources that's available. But it gets tricky because it's either you look at containerization or cloud native when you do this kind of setup, because it's much easier to spin up a container and scale it to so many instances than with a physical server, because it will take time and resources that needs to be available for you to do that. And then obviously resource pooling is the part where it takes from the resource that's in the pool, right? And that's basically how the features of cloud computing work. So if you have a server with 8 gig RAM, let's run 8 gig RAM, maybe 16 gig RAM or 64 gig RAM, and it's idling, the resource pooling will take from that availability to add that to the cluster so that application would use that service resources. All right. And now let's look at cloud computing services and deployment. So we have this, and this is where we're getting to where I showed you this earlier, where I told you that you have infrastructure as a service, you have platform as a service, and you have software as a service. And so when you look at these models here, you have infrastructure, which covers basically everything, right? So if you go to a cloud provider and you say, I want infrastructure as a service, you're basically going to have all of this running on your model when you basically borrow that resources, or like I said, the metered model. If you feel like you want to have a platform as a service, you might just run the platform, or you just, and they would then run the rest of it, right? And if you have software as a service, that now basically means that you basically run everything and that's needed. Now, when you look at the model, this is outside. This is your layers, how everything is set out based on software as a service and platform and infrastructure. In-house, this is how you would use it, right? So your cloud service provider on software as a services would basically be responsible for everything because you're borrowing the software as a service. So for the likes of any cloud model, let's say Blackboard, Sakai, Moodle, all those learning management systems, right? If they would run on the cloud, they would be more or less there as a software as a service. Then the cloud provider are responsible for the whole model. They are responsible for network resources, storage resources, compute, virtualization, the network operating system or the cloud operating system, the middleware, the runtime environment, the data that's stored on this learning management system, as well as the applications that's running on top of it. That is the cloud provider's responsibility because you're only using the software that's available on that model. When you look at platform as a service, you now have this part here that's broken down. What it means is that the data and applications is your responsibility, right? So this would be, let's say, MS Office, Microsoft Office, right? Because what happens with Microsoft Office is that um, your data that's stored from the end users or the clients are stored on their thing. But it could also be Microsoft Office could be a software as a service because if you don't locally own the data, Microsoft will store your data and migrate and delete and do what they want because you have their model as a software as a service. And so that's why people are very tricky when it comes to the cloud. You need to understand legally and everything you need to understand because your data could disappear if you don't have that right model. When we look at platform as a service, it can be many things. Data that's your responsibility in the application. So you would run the application and the data would be stored and that would be your responsibility. When you look at infrastructure as a services, now you have this model where you now want to use a particular operating system, and so you would be responsible for the OS, and the service provider, cloud provider, would give you a slice of how many virtualization do you need. Do you need to have how many cores do you need? How many compute resources do you need? How many storage do you need? They will provide that because they're responsible for that. But then everything that you do, middleware, runtime environment, data, and application, it's your responsibility. You are in charge of that. And that is basically when you look at infrastructure as a service, that you borrow like a virtual machine from the cloud provider, and then you are responsible for the rest of that. And that's basically infrastructure as a service. So when we look at deployment models, so you have different cloud deployment models. The one deployment model that we commonly use is the public cloud, where everything's in the cloud, everybody accesses the cloud, it's all fun and games, right? But then you have a company that really doesn't like the cloud. He wants to keep his data for himself. These are big organizations. They want to keep everything private. And so they basically own everything. Everything is managed by them. They don't have any cloud provider involved, and that's okay. But when it comes down to scalability and scaling up, they might have problems because the cloud might be in one location and not across the world, right? And that's why you look at public cloud. But then you have the hybrid cloud, and the hybrid cloud now is a combination of the two, where you have both working together. You have your private data sitting in your private cloud, and you have your public data sitting outside, which would probably not be more confidential information. And then you have the hybrid approach, which now have a kind of a firewall or gateway in between that allows you now to store your data privately, which you need to keep private, and then public, which you'd probably leave in the public. But you have a hybrid cloud model where both is basically talking to each other through some sort of VPN, some sort of gateway, depending on how the setup would look. Right. And now let's look at our last part, which is mainstream and cloud computing vendors. And I think what I will do is today we'll just end here. This was like I just to give you the cloud basics. Tomorrow we'll go really in detail with networking basics, storage basics, server basics, because that is really where it will get tricky and you need to really concentrate. So today was just this overview I wanted to give you, and then hence why we started at 11. So let's look at mainstream technologies. So mainstream technologies again, like Huawei Cloud, one of them, they're out there. And what you would normally see is you would see these acronyms, right? ECS, OBS, EVS. It's all new to you, right? But I mean, you need to understand what this means, and the only for you to understand how it means is to practically really, do this. So with Elastic Computing Service, it's basically the equivalent of the EC2 of Amazon, which is a virtual machine that you're basically running. It's also equivalent to running a virtual machine in Microsoft Azure, or in Google Cloud where you use a compute engine. All of that is all similar to even IBM. So all these companies, what they do is, even this one here, Alabama, and then VMware have obviously VMware Sphere, right? Or VMware Workstation. But all of this that I highlighted in purple is the same thing. They're all basically there to give you a platform as a service, well, not platform, infrastructure as a service, right? That's the ECS. And then you have obviously object storage, which is more object storage is similar to S3 from Amazon. You have blob storage from Microsoft. So you can see basically the same definition of a service, just each company or vendor gives it a different name. They don't want to be sued. Huawei can't go call something called EC2 in their stack. Amazon will sue them. And you know that the competition between Amazon is American, so this is US versus China, and you obviously don't want to have friction here. So they don't want to have that friction. So what they do is they give each other different names for the products, although it's the same definition. So when you look at elastic volume service, right, EVS, you probably won't know what it means, but it basically just blocks storage. And so when we look at storage, when we go to storage basic later on, you will see tomorrow or Thursday, we will see basically that elastic volume service, it's similar to a block storage, which we would have on any other vendor like Google Cloud Storage or IBM, not IBM Object Storage, probably some other name for it. They all have different names for these things, and that's basically how they operate. But the beauty of Huawei Cloud is it shows you really virtualization, how it works from the back end. Whereas all these other vendors that you see here, they are just going to give you the front end. They are just going to show you the nice look and feel of the website, how you take a service, and so forth. And that's basically how they operate. And so when we look at, and we'll go through that now just to basically give you that perspective, but that's basically how this vendor works and all these technologies. So you might look at Huawei and see, oh, you only see some of that. There's about 200 services. Amazon, there's also about 200 services. I don't know about Microsoft, but there's about 200 services that you need to know for each of these vendors if you really need to know what each service does. And that basically allows these guys to operate the way they operate. So there's your Huawei Cloud. It's called Everything as a Service. And so we have many other companies that use these services. You have the government, you have financial customers, you have car manufacturers, you have e-commerce companies, you have gaming people. So if people want to borrow the GPU, GPUs from from the cloud, they would run their games and store everything in the cloud, and the clients would just connect to that. You have audio and video enterprises. You have SAP, right? SAP also ERPs, and also planes that obviously use the cloud to send information while they travel. So that's basically how the cloud operates. And in this case, this is just the model showing how Huawei operates with their cloud. So there you have, oh, I said 200, there's 240. Just declining my calls here, sorry about that. Okay, let's just stop that. So again, when you look at that, you would basically see that um, there's over 240 Huawei cloud services. Okay, I said 200 earlier. That means that there's many, right? So you can see a compute. There's your ECS, right? Elastic, what's it? Elastic, I don't know, I forgot the name now. You see, so you need to understand these acronyms. There's block storage. I'm not sure what that acronym means. Could be availability zone, or I don't know. But again, these are how they label these services. There's your storage, there's your volume storage, there's your object storage, and there's a file storage. So there's three different storages, and we'll learn that later on when it comes to storage services. Three different storages. There's block, there's object, and there's file storage. Those are the only three. You don't get more than that. And then obviously there's container, security, the databases. All of these are all services that you see on the front end. So if you use the cloud, you would see these services. The back end, it's all virtualization, all virtualizing all of this to work. So again, there you have the Huawei Cloud Stack. Again, gives you the whole way of how you can use it. With regards to using AI now, also they have AI enablement, which means that you can use the AI in the cloud without running AI on your premises. That's also available. And so it's one cloud tailored for anybody's enterprise's needs, right? And that's basically it. Now, when we look at Huawei Fusion Compute, these are the part that we'll get to, right? Because in this particular course, you learn about Fusion Compute virtualization. However, this is the basics we're covering. If we do the full HCIA, right, the whole HCIA, you would have to learn Fusion Compute virtualization, how it works. For now, we're looking at the basics only. And so again, Fusion Compute is Huawei's basically cornerstone of how they operate. And then on top of that, you then have Huawei Cloud and the hybrid cloud that connects, to the two. So this is the link between the two. So you have Fusion Compute that's running here. We probably have on your campus, on your premises, they would run the Fusion Compute virtualization. But then if you go to the cloud, you then have the hybrid cloud or the Huawei cloud that interacts. And that's basically how everything works with regards to that. Now, if you look at the comparison between the two, between the three, you have, Fusion Compute, which is just a virtualization solution. And we'll go through that this is like similar to VMware, but it allows you basically to use KVM, bare metal hard servers to do that. Again, it's there for the enterprise. It's physical services, network devices, and storage devices that allows Fusion Compute to work. And you need to purchase obviously hardware devices. And so it's a data center virtualization, and you can run a VM, like I said, a VM or a container on Fusion Compute. VMs you can run Windows servers and so forth. When we look at Huawei stack, the Huawei stack again is a different story. The Huawei stack again is a hybrid cloud. This means that you have a combination of these two, um, or OpenStack, because I forgot there's OpenStack also. That's somewhere here. And so OpenStack is somewhere in between. Not really covering OpenStack in this series, but OpenStack again, it's there basically. It allows you to obviously use the physical services and the network devices, And that's more or less a subscription services. You would have a pay-as-you-go model there with our Huawei cloud stack, because there's only 90 cloud services. So from the 250 that you saw here, for the Huawei cloud stack, you have basically services here that you would only use, as part of that 90 cloud services. And then you have the Huawei cloud, which again here is the whole platform. Everything is there, public cloud, hybrid cloud. You don't need any hardware there because you use pay as you go. You have a pay as you go, right? So no hardware needed. And there's over 240 cloud services, right? So that is, basically where I wanted to end today. And so again, when you look at, the statements that we mentioned earlier, the small pop quiz would be like, which of the following statements are true about challenges, right? We mentioned earlier, service rollout is very slow, so that's true. Expansion is difficult. It's not reliable. And the turn, what's it called? TCO, uh, um, total cost of ownership, is very high. So in an exam, if you get the Huawei exam, these all four would be right. In Huawei likes to mark you negative. So if you had to miss one, you would lose marks for that question, whatever it calculated or valued. That's basically how they set up the exam. So just heads up if you ever plan to do the exams. And then the cloud computing deployment scenarios is public cloud, private cloud, and hybrid cloud. So that is true. Right. So that's basically what I wanted to cover today. I know we spent it probably is an hour, but I think tomorrow I want to really go into detail with it, because now you know the basics. You have access to those slides. I'll try to see that slides in the WhatsApp chat also for you. And then really tomorrow we will really want to go through everything nicely in detail, so that you really understand, everything, how everything works. Now, before everyone disappears, I just need to take a screenshot of your faces. So I want you for 1 second, well, 5 seconds, just switch on your camera, and then I'll just take a screenshot of everybody here, because I just need to have all of you that's here, that's a participant, saved for my record purposes. So if you can, just switch your camera for 1 or 2 seconds. I'll take a quick screenshot, if you don't mind, and then that will be my evidence that you attended the class. And then tomorrow we'll start at 9 o'clock. Right. So you can do that now. So the quicker you do it, the quicker we can finish off. And then the recording, I'll share the recording with you guys also. I'm just stopping the recording.